Oh, hi. Thank you, Henry. I'm glad to talk here, and I want to share the current research activities of my group. So I direct the Robotics and Automation Lab in EC department. And our focus is to develop system and algorithm solutions for intelligent mobile robots for the socially compliant behaviors. And we want to enhance the seamless human-robot interaction. This slide shows the active projects, 3 projects I want to highlight. That the first project is an SFRI project that we developed the dynamic robot guides so that robot can interact with the pedestrian flows by controlling the speed and traveling trajectories of the mobile robot. We can control the desired speed of pedestrians so that not a lot of people go through a bottleneck area, so that we can control the traffic jam. For example, on the left bottom picture, in the intersection point that, in the intersection area that the 2 different flow merge, that's a bottleneck area. And if we want to control the number of people get into the bottleneck area to reduce the traffic, we can have a robot going with a pre-designed trajectory and adjust its speed according to the number of people and the speed of the pedestrians, so that there's the right number of people in the merging area. So hopefully this may be applied to the crowd management applications, so that reduce the risk of stampedes. So that's one of the projects we are ramping up. That was a 4-year project. And we're currently working on the understanding pedestrian dynamics project, that is an NSF M3X project, and also another project, aging in place through enhanced mobility and social connectedness, which is the NSF Smart and Connected Health project. So for the rest of the time, too much. So I'm going to talk about the second and third project. Okay, so this is a project that we want to understand the pedestrian dynamics and to teach the mobile robot navigate in crowded place in human environment. So the video on the right you see is using the real data collected in Japanese shopping malls that pedestrians navigate in a shopping mall environment. The red color is actually a robot, which is very small. Red color are the laser scan signal that the robot has a 360-degree laser scan. It can detect the people in around it. So the motivation is that humans navigate in small area in crowded place smartly. They reorganize, reconfigure, and can unconsciously follow the other pedestrians if there's not much time. But current robot navigation strategy, it's not very efficient. It may freeze using the current my third, so our goal is to learn how humans navigate using the existing data sets, real world human navigation data set, and use that to teach the robot to navigate in a socially compliant way in human environment. So the learning method we use include the inverse reinforcement learning and the GALE, generative adversary imitation learning. So in the interest of time, I move on to the third project, which is integrated robot and wearable sensor system for enhanced mobility. So in this project, our goal is to develop autonomous robot guide that can teach, that can lead elderly people in guided walking. We want to use a mobile robot to lead the elderly people in 15 minutes walking exercise, and the robot work with in-shoe sensors. I collaborate with Professor Damiano Zanotto in mechanical engineering on this project. He has a wearable sensor systems, and we developed the data fusion methods so that the wearable sensor data can be real-time passed to the computer on the robot. Robot can online monitor the gait information and send alarm if the elderly people has a gait problem, so that there's a risk of falling, we'll send alarm, and also can monitor the status of the walking exercise. So yeah, the left figure is of a student where the in-shoe sensors and be guided by the robot in a walking exercise. And the Vicon camera is not part of our system, but it's used for ground truth comparison. So we want to compare our system with more expensive fixed infrastructure like Vicon camera systems on the performance, including accuracy and real-time performance. So for the interest of time, I think I can stop here so to catch some time.